So this is the third session on friction. This is in continuation of the second video. So in this video also I'll take up a new theoretical discussion on static friction. Okay. And one more thing I'll discuss. Okay. So first of all, in the second and first video on friction, we have discussed kinetic and static friction forces. Okay. So now for static, let Fs denote the static friction. Fs denotes the static friction force between two solid bodies in contact. Fs denotes the static friction between two surfaces in contact, and let n be the normal reaction. Fs is the magnitude of static friction. Okay. So for no slip, Fs is less than equal to mu Sn. This is called the coefficient max force of limiting friction. Mu s is called the coefficient of static friction. N is the normal contact force between the two surfaces in contact. Fs is the magnitude of static friction that lies between these limits. Okay. Now this mu Sn is called with various names. Mu Sn is called the force of limiting friction. Force of limiting friction. It is also sometimes referred to as Fmax, maximum possible magnitude of static friction. Sometimes we also call it as supply, or sometimes we call it as availability. Various names are there. Okay. The implications of this inequality has already been discussed in the second video on friction. This inequality indicates that in order to prevent relative slip, static friction can assume any value between 0 to mu Sn. Okay, so it means that static friction is a self-adjusting force. Alright. Now, we also talk of the concept of requirement. What is the requirement? What is the meaning of word requirement? Requirement means amount of static friction needed to prevent relative slip. That is called requirement. The requirement means amount of static friction needed to prevent slip. Amount of static friction needed to prevent slip. That is called the requirement. Okay, fine. So amount of static friction needed to prevent slip. That is the meaning of the word requirement. Okay. So in order that no slip takes place between two surfaces in contact, condition for no slip will be stated in this way. For no slip, NS meaning no slip between the two solid bodies in contact. Between two solid bodies in contact. For no slip between two solid bodies in contact, requirement should be less than equal to availability or Fmax or supply or force of limiting friction, whatever name you may call it. Or Fmax or mu Sn. Okay. So this is the condition for no slip. NS meaning no slip between two solid bodies in contact. Requirement should be less than equal to supply or Fmax or the force of limiting friction, whatever data you may call it. Alright, fine. Write up this first column. So suppose there are two solid bodies in contact. Okay, there are two solid bodies in contact, suppose. So if actual slip takes place, implies the friction force acting between the two bodies will be kinetic friction, and that is equal to mu kn. This is the condition for slip. Fk equal to mu kn. Okay. For no slip, friction force should be equal to static, and that should be less than mu Sn, more than equal to 0. For impending slip, F is static friction. Friction is static in nature, and its magnitude is just equal to mu Sn. So here I talked that for no slip, requirement should be less than equal to supply, and here I am telling for no slip, Fs should be less than mu Sn. This condition also I have counted in no slip only, so that's why here less than equal to sign is there, and here there is only less than. I hope it is clear what I am saying. They appear to be mutually contradictory, because here I have said that for no slip, requirement should be less than equal to supply, less than equal to, and here I am saying for no slip, Fs should be less than mu Sn. Here it is less than equal to, here it is less than. They appear to be mutually contradictory, but impending slip also I have counted in no slip itself. So this less than this or equal to this is equivalent to less than equal to this. So there is no problem, okay. So if actual slip takes place, the force of friction between two bodies is kinetic friction. Its magnitude is equal to mu kn. N is the normal reaction between the two bodies. Mu k is the coefficient of kinetic friction. For no slip between the two bodies in contact, friction is static in nature, and its magnitude is less than mu Sn and more than equal to 0. And for impending slip, friction force is static in nature, and its magnitude is equal to mu Sn. Impending slip meaning it is about to slip. Okay. So here I have counted this also in no slip itself. In this case, that's why I wrote it here, less than equal to. Here I have only written less than. So I hope it is clear what I am saying. Fine. All right. So these are three kinematical conditions. Actual slip, force of friction is kinetic in nature, and its magnitude is equal to mu kn. For no slip, F is static in nature, Fs, and its magnitude is less than mu Sn, more than equal to 0. For impending slip, force of friction is static in nature, and its magnitude is equal to mu Sn. Okay, but in numericals we will not distinguish between these two. We will simply write them like this. For no slip, requirement should be less than equal to supply. Okay. In condition for no slip in numericals, we will use this condition. We will not use this one, because this also I am counting in this itself, no slip itself. Okay. So this I have made it clear. Fine. I'll wrap this. Okay. Now, I'll talk of usual behavior. See, this is very important. Usual behavior. Now, what is this usual behavior? To demonstrate this concept of usual behavior, I'll take a numerical example. Okay. Suppose we are given a rough horizontal surface. Suppose a block of mass is placed here. Suppose the mass of the block is 2 kg. This is a rough horizontal surface. Coefficient of static friction between these two blocks bodies is 0.6. And coefficient of kinetic friction is 0.58. Okay. This I have already discussed in the previous videos, that for a given pair of surfaces in contact, mu k is less than mu s. Okay, fine. So now suppose this block is initially at rest. This block is not slipping on this rough surface. Okay. Now suppose an external horizontal force is applied to the block, which depends on time as F external equal to 2t. Here small t denotes time. Okay. Now G will take to be 10 meter per second square. G will be taken to be 10 meter per second square. Okay. Fine. Now I draw the free body of this block, 2 kg block. One weight 2g exert, which is 20 Newton in downward direction. The ground exerts a normal force N on the block in upward direction. And this external force causes the block to slip in that, tries to cause the block to slip that side. So there is a tendency for slip. So surface will exert a friction force small f on the block in leftward direction, opposite to direction of tendency for relative slip. Now what is the force of limiting friction between these two bodies? It is just equal to mu s n. Mu s is how much? 0.6. A normal reaction is how much? 20 Newton. 2g. That is simply 12 newtons. Okay, fine. Here t denotes time. Alright. The block is initially at rest. Static, okay, static block. This surface on which it is placed is also at fixed. Okay, with respect to ground. Okay. So now what I do, I make a table here. Serial number. Okay. T denotes time. F external denotes the value of external horizontal force at a time instant small t. Here I add requirement. Requirement meaning amount of static friction needed to prevent slip. Actual friction force acting. F is the actual amount of friction force acting. Then we will find the nature of friction, whether it is static or kinetic or rolling, whatever it is. Okay, but rolling we are not going to discuss. So here nature of friction force. And last, status, kinematical condition. Whether it is slip, whether it is no slip, whether it is impending slip. So kinematical condition, status. Status meaning kinematical condition between the block and the surface in contact. Whether it's no slip or impending slip, whatever it is. Fine. Now serial number 1. Okay. Suppose t is 0. T is 0, the F external is also how much? 2 into 0, 0. So at time 0, external horizontal force is acting on 2 kg block in rightward direction. So to cause no slip, friction amount, needed amount is also 0. So requirement becomes 0. What is the supply? 12 Newton. So friction is not needed. So friction won't act. Okay. So value of friction is also 0. Or nature of this friction. Here see, nature we should not say anything because friction is not acting. But still if we want, you can put the nature as static here. Okay. Actually friction is not acting at all. But still you can say static in nature, static. Alright, fine. And then status. Status is no slip. So in this case, see, one thing I'd like to just emphasize. Here amount of friction needed is 0. What I'd like to say that friction needed is 0 and 12 Newton is maximum available. So in this case, we will say that friction is present but is not being used. It is not being activated. Why? Because friction only has a single point objective, to prevent relative slip. Friction sees in this case that even if it doesn't act, there is no slip. So it won't act. Its objective is being fulfilled. Okay. For example, there is a police force somewhere in some locality. They fear that some disturbance may take place in the society. But police force sees that even if they don't fire, peace is being maintained in that locality. So they won't fire. Because objective of police force is only to prevent relative slip. So to prevent any disturbance in the society. So if they see that even without firing also there is no disturbance, so what will happen? They won't fire because the objective is being fulfilled. So similarly, aim of static friction is to prevent relative slip. Its only objective, whole sole objective is to prevent relative slip. Friction sees that even if it doesn't act, then also there is no slip between block and the surface. So it won't act. So we'll say that friction is present but is not acting. This will say. Fine. Serial number 2. Say t equal to 2 seconds. External horizontal force becomes 2 into 2, 4 Newton. Now, if 4 Newton force acts here to prevent relative slip between 2 kg and the surface, amount of friction needed also becomes 4 Newton. So requirement becomes 4 Newton. Now what is the maximum possible friction available? Possible 12 Newton. How much is needed to prevent slip? 4 Newton. Present is 12. We need only 4. So what is the actual amount of friction which will act? 4 Newton. In this case, we will say that requirement is being fulfilled. To prevent relative slip here, amount of friction needed is 4 Newton. Available is 12 Newton. So only F4 Newton will act. Okay. Suppose analogy of this is again, take the example of police force. Police force sees that just by firing, just by 20 police personnel, peace is maintained. So why should they bring 30 personals? Why should they become 30 police personals when peace can be maintained only by 20 personals? So 4 Newton is needed, and what is the maximum availability? 12. So 4 Newton will only act. Friction only exert that much. Friction will only exert that much value, so that the no slip is being fulfilled. So its condition is being fulfilled. So only 4 Newton will act. Present is 12, but only 4 Newton will act actually. Okay. Now what is the nature of this friction? Since it is no slip, it is static friction. Okay. Now what is the status? Again, it's no slip. It won't slip over the surface. The status of this is no slip. Fine. Alright. 3. Suppose the time is 5 seconds. Okay. Then external force becomes 10 Newton. Now if external force of 10 Newton is acting on this 2 kg block, to prevent relative slip here, friction should also be equal to how much? 10 Newton. So requirement becomes how much? 10 Newton. So 10 Newton friction is needed to prevent slip. Actual amount of friction available is 12 Newton. It can supply up to 12 Newton. Only 10 Newton is needed to prevent slip. So only 10 Newton will act. So actual friction which will act is also 10 Newton. In this case also, we will say that requirement is being fulfilled. Maximum available friction is 12 Newton. Only 10 Newton is needed. So requirement is going to be fulfilled. Okay. Now what is the nature? Again, it is static friction. Nature is again no slip. NS meaning no slip between the 2 kg block and the surface. Now fourth option. Suppose you take t to be 5.99 second. Then what is the amount of external force acting 2 times this? 11.98 Newton. So what is the requirement also? Requirement also becomes 11.98 Newton. Requirement also becomes 11.98 Newton. This is the requirement. Now what is the supply? 12 Newton. How much is needed to prevent slip? 11.98 Newton. So requirement is again going to be fulfilled. So actually how much friction will act on it? 11.98 Newton friction will act. Again, nature of this friction will be static because there is no slip. And status again will be no slip. Okay. Fifth one. Suppose t becomes 6 seconds. External horizontal force becomes 2 into 6, 12 Newton. So now 12 Newton friction is needed to prevent slip. So requirement again becomes 12 Newton. So 10 Newton friction is needed to prevent slip, and 12 Newton friction is available. So we'll say again that requirement is being fulfilled. The actual amount of friction acting will again be 12 Newton. Now what is the status? This again static friction. Now what is the kinematical condition? Status is what? They will write impending slip, IS. IS meaning what? Impending slip. IS meaning what? Boliye, tell me, what is it? Impending slip. That is, it is now about to slip over the surface. Just going to slip now. Just slipping is going to start. Serial number 6. 6.01 second, okay. external horizontal force becomes 12.02 Newton. Alright, fine. Now what is the requirement? The requirement also becomes 12.02 Newton. But what is the availability? 12 Newton. We require 12.02 Newton of friction to prevent slip at t equal to 6.01 second. But maximum friction which is available is only 12 Newton. So in this case requirement cannot be fulfilled. So actual amount of friction needed will be 12.02, but friction available is maximum 12. So now what will happen here? First of all, nature of the block will begin to slip over the surface. So nature of the force changes to kinetic friction X. And here in status, actual slip takes place, S for slip or only slip. And what is the amount of friction needed? Since the slipping has started, the friction now will be kinetic in nature and its magnitude will be mu k into 20, 0.58 into 20 and 11.6 Newton. Okay, so this data which we have gained. Okay, now see, I wrap this one. Okay, fine, all right. Now see, in this numerical example, what do you observe? When t is less than equal to 0 to 6 seconds, till this instant, in the time interval t 0 to 6 seconds, amount of friction force acting is just equal to the applied external horizontal force, which is just 2t. You can see till 6 seconds, small f and f external exactly match each other. They are exactly equal. See, 0, 0, 4, 4, 10, 10, 11.98, 11.98, 12, 12. So long as t lies between 0 to 6 seconds, amount of friction force acting between the block and the surface is numerically equal to the externally applied horizontal force. And when t exceeds what? 6 seconds, and one more thing, in this interval 0 to 6 seconds, the block does not slip over the fixed surface. So acceleration of block is also 0. Okay. And when t exceeds 6 seconds, okay, t exceeds 6 seconds, then we see that slipping starts. See, till 6 seconds there was no slip. That is, the block was not moving over the fixed surface. So acceleration of block with respect to ground is 0. And when t exceeds 6 seconds, the block begins to slip over the surface. The block begins to slip over the surface. And then the nature of friction changes to kinetic. Its magnitude is equal to mu kn. Okay, fine. The block begins to slip over the surface and then nature of friction changes to kinetic. Its magnitude becomes mu kn. In this case it becomes 11.6 Newton. And the body begins to slip. That is, acceleration of the block becomes more than 0. Okay. So this was just an example. But what conclusion we can draw from this? We can draw the following conclusion. Okay. I rub this one. Okay. I rub it. Okay. See, observation which you draw from this is this, that from this numerical data what we see is that if t lies between 0 to 6 seconds, then friction is just equal to the externally applied horizontal force and there is no slip between block and the surface. That is, acceleration of block with respect to ground is 0 and nature of friction is static. When t exceeds 6 seconds, then the block begins to slip over the surface. nature of friction changes from static to kinetic. Its magnitude becomes 11.6 Newton in this case, and the acceleration of block with respect to ground exceeds 0. Okay, so this is the usual behavior. In this case, see, if I draw the graph of small f versus capital F. Okay, then so long as t is less than or equal to 6 seconds, they are equal. So y equal to x is the equation of straight line passing through origin in the xy plane and making an angle of 45 degree with the positive x-axis. So f equal to f external is the equation of a straight line in the passing through origin of this plane and which makes an angle of 45 degree with the external horizontal force. This is true so long as f external is equal to less than or equal to 12 Newton. Friction also becomes equal to how much? 12 Newton. And when external horizontal force exceeds 12 Newton, then slipping starts to take place. And nature of friction changes from static to kinetic. And after that, friction remains constant. Constant value of how much? 11.6 Newton. So in this region, f external lying between 0 to 12, nature of friction is static. And there is no slip. NS meaning no slip between the block and the surface in contact. And when f external exceeds 12 Newton, the nature of friction becomes kinetic. And slip begins to take place between the block and the surface. And this marks a transition from static to kinetic. This is called the kink. This is called the kink in the graph. Okay. This is called the kink in the graph. Kink. It's called a kink. Okay. So this is usual behavior. Okay. Fine. Now I'll rub this first column. Okay. So now how do we generalize? This was a specific example. 12 Newton, 11.6 Newton, t 6 seconds. But how do we generalize this usual behavior? See, this I'm talking about this usual behavior. It is very important because we deal those kinds of problems. 2 block problem, a 3 block problem, one resting over other, external horizontal force acting only on one block. For all pairs of surfaces, mu s and mu k are given. For given value of f external, we have to find the acceleration of blocks and the friction forces between the blocks. There, this concept of usual behavior will be used very much. So that's why I am emphasizing it. Okay. So I'll just summarize this usual behavior here. Usual behavior is this. There is a fixed surface, fixed rough surface. It may be horizontal, it may be inclined. I am showing it just for the sake of argument. I am showing it to be a horizontal surface. There is a block here resting here. Mass of the block is m. The friction coefficient between block and the surface is mu s, static friction coefficient, mu k, kinetic friction coefficient. The block is initially at rest over the surface. External horizontal force is applied to this block in rightward direction, in horizontal direction. Because of this f external, this block has a tendency to slip over the surface. The surface exerts a friction force on the block in leftward direction, opposite to direction of f external. In usual behavior, we say like this. Here, normal force on the block due to surface is N, which is just equal to the weight of the block. Okay. Now, usual behavior is this. If f external is more than 0, less than 0, more than equal to, and less than equal to mu s n, that is the force of limiting friction. In that case, amount of friction acting on the block will just balance the external force and the block will not slip over the surface. That is, acceleration of block with respect to ground will be 0. Okay, until so long as f external lies in this range, there is no slip between the block and the surface in contact. No slip between the block and surface in what? Contact. There is no slip between the block and surface in what? Contact. And I love that one. Okay. And when F external exceeds this limiting friction, if F external exceeds mu Sn, then the block begins to slip over the surface, nature of friction becomes kinetic, and its magnitude becomes mu Kn, opposite to the direction of F external. The block begins to slip over the surface, and friction becomes kinetic in nature because of slipping, and its magnitude becomes equal to mu Kn, and acceleration of block with respect to ground becomes more than 0. This is the usual behavior. Okay. So what is this usual behavior? I'll just emphasize it again. I'll state it again. This is a fixed rough surface. It may be horizontal, it may be inclined. I have shown it horizontal here. A block of mass m is resting over this rough surface. Kinetic friction coefficient between block and the surface is mu k. Static friction coefficient between block and surface is mu s. Here normal force acts on the block due to surface. Weight acts on the block due to ground. External horizontal force is being applied to m in say rightward direction. Now because of this external forces, block will have a tendency to slip over the surface. So the surface exerts friction force F on the block in opposite direction to F external. Now usual behavior states that if F external lies between 0 to limiting friction, then this is just equal to this, and acceleration of block is 0 because the block doesn't slip over the surface. And if the nature of friction is static and there is no slip between the block and surface in contact, that is acceleration of block with respect to ground is 0. Alright. If F external exceeds mu Sn, then what happens? The block begins to slip over the surface. Nature of friction changes from static to kinetic, and its magnitude becomes mu Kn, and acceleration of A of block becomes greater than 0 because it begins to slip over the surface. This usual behavior I have talked of. Okay. So now in coming videos, first I'll take up numericals on kinetic friction. Several types of numericals I'll take up from kinetic friction. I'll also take problems on JEE Mains and JEE Advanced. Okay. And I'll take all sorts of problems. And then I'll pass over to the finding acceleration problems, which I have stated just now in this video also. Several blocks, one above the other. External horizontal force is being applied only to one block. For each pair of surfaces, mu s and mu k are specified. We have to determine the acceleration of each block and the friction forces between the blocks for each even value of F external. So that we have to, those kinds of problems I'll discuss. So this was the third video. I hope it is clear. In case you have any doubt, you put your doubt in the comment box. I'll look into it and clarify it. Okay, so I close it here. Fine.